So you'll be fairly familiar where we are, the East Lachlan within the Macquarie Arc. The cargo district there, about 5 k's off the west side of Cadia Valley project boundary there. Obviously globally significant gold copper producer. Other notable producers there, Cal, and since Evolution acquired that, they've made some great brownfields discoveries, taken that forward, and they're starting to reap the rewards with some of the cash flows they're seeing. North Parks we're starting to hear a bit more about. Now it's in the hands of ASX Evolution, and some great discovery stories still emerging from this part of the world. South of Tomingley there, the Boda discovery, north of Cadia. Still surprising, and still sort of working out, how these systems are linked. Still a fair bit of work to be done there. What we liked about the opportunity at Spur was we feel there's a really poorly tested target style off the boundaries, off the shoulders of these Benambran age intrusive complexes, which have often got quite encouraging intrusive hosted porphyry mineralisation associated with them. But often the shoulders and these wall rock hosted positions are poorly tested. And also just the realisation with the overall industry's knowledge breakthroughs via these discoveries of the potential important link between the alkalic epithermals and the juicy, we'll call them alkalic porphyries, within those complexes. So in time, it's useful to start to think about where we are in the arc and sort of the 3 main belts. The basement of the arc there, phase 2, as it gets described as, deep water, the roots of the arc developing. Really important to see that. I've sort of worked in these rocks for nearly 17 years, and it's a key marker unit when you see those fine deep water sediments, volcanoclastic turbidites essentially. And quite a lot of the mineralised systems have a strong stratigraphic control, which you don't always think about in porphyry world. But for example, wants to play the game. Ridgeway there at the top of the Wamala Formation in the Molong Belt. As you step up into the more oxidised stratigraphy, if you like, it's obviously a key stratigraphic position and a stratigraphic control. Boda was also interestingly, discovered at that broad interval, coming up sequence from these volcanoclastic turbidites, very much structurally deformed. But once you'd pull that apart, you can see the importance of that stratigraphic transition. And so this sort of is informing very much what we're doing at Spur. It's important that we have got that preserved, that stratigraphic transition. Other important elements of this are the Llandovery basins, which clearly conceal very, very important sort of timing and conceal the Cadia East system. So there's some evidence that we've got that at Spur in that cargo district as well. But it's also, it's arc magmatism progressing into post-collisional magmatism. You can see there is a really important sort of setup here at about 445, post-collisional magmatism, which happens above this sort of key limestone marker unit. So you can sort of start to track where you are, almost regardless of where you are within the 3 belts. And it's, it's fascinating to see the hydrothermal alteration mineralisation starting to show patterns. Just throw this one up, Chris Leslie's work, PhD work he did quite a few years ago now. And there's been some big breakthroughs, in my opinion, whereby we're starting to see a bit of a link between how the epithermals might fit in to some of the porphyry metallogenesis throughout the belt. Also, you see in these sorts of plots, that's that limestone marker unit, the second major hiatus. It gets called hiatus 2 sometimes. Estonian age limestone, which, it starts to become pretty useful. So you can see the cluster of fairly newly acquired ages. He's done a great job to pull apart the complexity, multiple phases and cycles within that Cal system. And he's starting to link to different chemistries of porphyries and obviously all the epithermal gold. Whilst they're not really targeting porphyry there, because they've already found 14 million ounces of epithermal gold, so why would you? But there is a really interesting You know, the research is sort of coming up with some interesting findings in terms of the associations there. So you start to see multiple cycles. So traditionally, we're very much used to talking about just arc magmatism goes into the alkalic field, i.e. the economic field, just once after the Estonian. Clearly, that's sort of not the case. Regardless of this as well, of course, there's significant older gold in places like Cowal as well. So we're not sort of so hung up on this, but I just think it's interesting with the work that we're doing at Spur. It's actually lending itself to a lot of what's shown here in terms of you know, these red dots are the Molly dates, so they're sort of tracking hydrothermal activity pretty well. This one here at Cargo Spur, for example, you know, this is an older date. Going and looking at that one again, it looks like it's in a class to me. So it looks like it's probably quite an old date within the mix, is what we would expect there. And I'll show you a photo later on where we've clearly got this limestone unit, which is being hydrothermally altered and veined. So field relationships, we're sort of only just starting down this path of let's just get another 30 geocron numbers here before we get too carried away with how we wave our arms around. But you can see the field relationships are in that Cargo Spur area. You know, it puts us up here straight away based on that limestone being hydrothermally altered. So again, just reiterating the exploration model that we're applying here, which in my opinion is just underdone throughout the belt. So you want to get off the main intrusive complexes, which are the big aeromag highs. You know, Benambran, really juicy. There's often a lot of copper, gold showings. And you know, it's not that the oxidised porphyries aren't magnetic as well. If they're shallow enough, they are. But the dominant magnetic feature are these sort of skarned, essentially early stage skarned intrusive complexes. And then you start playing this game in terms of alteration zonations, and so it's close, and it's amazing. It's amazing what you start to see if you just sort of take this thinking. And then the other element of this is, and Boda was a great example, but a lot of the Cowal discoveries are too, I believe, where you can see that these things are really vertically continuous. So the upper levels of these big systems can be epithermal gold systems with a great epithermal pathfinder suite. Not a lot of copper. So copper explorers, they're going into the belt as they did, and they gave it a really good shake. They weren't using geochemistry like we're used to using it these days. They missed these things. These things are out there still to be found. He says optimistically, the geologist. But Boda was a great example of that, I think, where you know you could see very significant discovery from surface with a different geochemical footprint than what was expected. So just making some comparisons. So Cadia, obviously very nearby, you know, Benambran multi-phase intrusive complex, big mag high, and you can see fairly quickly the importance of that early intrusive architecture. So Ridgeway, Cadia East, big wall rock porphyry systems, high grade, massive beasts. If you take them away from Cadia Valley, you'd still be excited, but you know, Cadia Quarry wasn't hitting it out of the park. So that's it. We're taking that sort of thinking. That sort of thinking led, you know, it led us on a productive path for Boda. We can see that sort of unfold. So we're looking in the equivalent position around this as the Cargo intrusive complex, and we can see, you know, at the same scale, you know, we've got plenty of room here. We just have to demonstrate fertility, and that, you know, we've got the right sort of alteration. So that's where our exploration has been sort of focused on. At Cowal as well, you see the importance of the early intrusive architecture in the epithermal systems. So they're off the edges as well. The big ones are off that early intrusive architecture. So, and you know, it's not that you don't see porphyry mineralisation in there, you do. Calc alkaline, it'll get called in these sort of older rocks. You know, more recently they're starting to pull apart, so for example at E41 at Cowal, you know, all this hematite, early stage high temperature porphyry alteration, pervasive hematite albite, which in the porphyry world is pretty encouraging. You know, if you're going and looking in the Macquarie Arc for oxidised porphyry systems, you pay attention to this red rock alteration. Some of what we're kicking up at Spur, you know, in the epithermal gold is notable in that, you know, there's a drill where the gold is, but also, you know, we point to sort of the significance of some of the hits that evolution were making very quickly as they were tracking Dalwhinnie and the GRA 46 discovery. So we're getting, 100 gram metre hits, very much similar to what they started getting here, 11 at 11. And it'd blow out every now and again to sort of 50 at 10. So very, very similar sort of architecture, local structural controls. We've got, just like at E41 at Spur, I'll show you some photos shortly, we've got the high temperature hematite and albite. That was one of the things we really liked about the project when we went and looked at the old drill core at Londonderry. And the high logger gave us those answers. So this was the rock here that really sort of set it off in terms of the high logger showed that there was a wide zone, 50 plus metre wide zone of K-spar albite plus minus tourmaline. A lot of red rock alteration, pervasive. So the right looking material in terms of, oxidised porphyry systems here. But an early stage event, we can see most of the gold here is a little bit later than this, probably not too much later. There's some skarns here as well, magnetite, hematite skarn. And overall, just encouraging, because these are high level features, hydrothermal features, so you start to think about, we've got good preservation potential here, ultimately for porphyries. This is where the gold's sitting generally at the moment, high grade material, so we sort of see a bit of a range of habits and veins, very fertile, very fertile sulphide stringer zones. These are carrying 124 grams. So just, it's telling you ultimately got a really fertile system on your hands here. Even when the rock's looking boring, it's still carrying, which is a great sign. Quite high temperature veins, some of these quartz are carrying magnetite as well. So a fair bit of historic shallow drilling. There's some deeper drilling, which is mainly testing the intrusive complex again to the north. And there's some interesting hydrothermal breccias here. But the main game for us in this exploration strategy is these epithermal zones, which as we're tracking them and drilling them, are continuing, and we're able to extend the distribution. But they're also, we're seeing that really strong connection and association with the hematite and albite. So you just look at these rocks and there's a big magmatic input. These are really juicy. So lots of numbers there, you can digest that, but you start to just drill down into these things. We're seeing an important sort of syn mineral, you would call it feldspar porphyry phase. We've got about 6 different porphyry phases currently we're thinking about that we think are sort of all mappable. And the imports probably are some of these basaltic units, just like at Cal. You start to see those local structural controls. And also the skarns. So the skarn zones, which obviously you pay attention to the geometry of where they're going, because that one's mineralised. This is some work that we did with Fleet Space with their passive seismic, so which was perfect in many ways for us, and it was a pleasure to work with them on this because a big part of our exploration model is mapping where those intrusive complexes are. It's not the direct, that's not where we want to be, but we want to be on the edge of them. So that's what I think, that's what we think this is doing. So you're seeing these crystalline intrusive blocks, which go sort of for 5 kilometres. There's 2 of them, sort of sub-parallel to one another. So these ultimately are where we would go sort of hunting for the porphyries, on the edges of these sort of features. You can get a sense for that already. Some of these shallow gold epithermal hits are sort of suggesting that's important. Good technology in terms of giving us, important, mapping out that important criteria, the intrusive complexes. And you can see most of the drilling and exploration up sort of in this sort of 500 metre zone in the northwest here. Good, really good scale upside here. Once we're building our story, keep momentum as a junior explorer, we've got to try and do this justice, because you can see big scale potential. This one here's got some good high grade rock chips right on the edge of this one. So at some point we're going to branch out, step out and start to do target definition work and build these other targets up as well. At the moment, we're excited about what we're seeing up in this part of the world. And we're going to be smart where we can, carry the momentum forward, use applied geochemistry, rock type characterisation, pathfinder definition. Already, this is early stages. We're just starting to collect this data. but in terms of the modern way of how you would explore in amongst a porphyry epithermal system. You can see already we're starting to see a strong sodic signature and phyllic. But very early days there, but that's where we're heading. And just some of the intrusive phases that we're seeing. Generally, some of the field rock relationships are indicating these are cross-cutting and younger. So there's some interesting sort of more alkaline compositions here that are clearly younger in the mix. These are the old ones that had been dated. These would have been called calc-alkaline intrusives in the past. Takeaway from that for me is it's a multi-phase system. There's a lot going on. There is some interesting sort of trends in compositions, and I think these are probably more the Sin-Min important porphyries ultimately. As I said before, we're only just starting this journey in terms of filling the gaps here. This is obviously a major Benambrin intrusive complex in the Lachlan that hasn't been explored in terms of the wall rock, porphyry epithermal potential. And you can see here, this is grading, this is decalcified limestone. We're pretty sure it's this unit here. We haven't dated that, but we're working with the survey to do that. So in the mix, when you see those sorts of things, which is veined as well and has an epithermal signature, straight away it brings this search space in time into the mix. So we are seeking a PhD student to help us with this. This little company will be very much on the front foot with bringing the research along, because there's so much work happening, places like Cal at the moment, which is, big steps forward and advances in knowledge. We want to make sure this story gets carried along in terms of the context there. And support from the Geological Survey, which is smart. We spent a lot of time down at Londonderry. Can't speak highly enough of sort of that facility, the core library, and what benefits we're getting out of that already. And that could be the end. No, that was basically the end. That's just a summary of what I've been saying. So, we've historically explored that cargo district for the intrusive hosted porphyry mineralisation. Important signs, a lot of smoke there, a low-grade resource for sure, but we think the main game here is getting off the shoulders into that wall rock setting, i.e. Ridgeway, Cadia East, Boda is in the same position, all the Cowal ore bodies are in the same position. So we're going to test that, and so far so good, we're getting some good results. And hopefully maintain the momentum that this sort of project deserves. Thank you.